Hello everybody. Alright, so this is going to be our second flipped lesson. This one is on rotations. So let's talk about the transformations that we've done so far. So far, we have done reflections, which is this first one up here. And we have done translations. So reflections, we had a line, and we treated the line like a mirror, and we flipped an object across onto the other side of our mirror. So that's a reflection. The next one we did was a translation. Translations where we take an object and we slide it around. Pretty straightforward. That one had a really simple rule that you guys played around with in our last lesson. The last one we're going to be working with here is called a rotation. A rotation, the idea behind a rotation is we're going to have a fixed point and we're going to have a given angle, and you're going to rotate a fixed point a certain angle. So let me show you guys what that looks like here. We're going to start off, let's throw down a point 1, 1. So we're going to rotate this point A somewhere. But in order to rotate the point A, we need a point. We're going to use the origin, and the origin is 0, 0. So I will put down the origin here. And we want to rotate at this point 90 degrees. So that would, all rotation, this is an important note you guys can put down on your notes. All rotations that we will be doing in this class are always going to be counterclockwise. So we're going to take A and we're going to rotate it somewhere here into the second quadrant. So I'm just going to show you guys this, and then I'll show you guys more of the notation and more of the general rules for doing these rotations. But your ultimate result will look like this if I draw a few lines here. So we have this. If we were to draw a little imaginary line, so we have a line coming from the origin to our point A, and we want to rotate A 90 degrees. So if I draw another segment here, the angle measurement of these two line segments is going to work out to exactly 90 degrees. So that gives us our rotation of 90 degrees of a fixed length going from a given point to our object that we're rotating. So going from our point of rotation in this place, in this case the origin, going to the point A and rotating that distance 90 degrees, giving us the point A prime. Alright, so let's get rid of all this stuff. We don't need this just yet. The first thing I'm going to ask you guys all to do is on your note sheet. Actually, let's take a look at notation first, and then we'll do a couple of examples of this. Let me clean up all of my workspace here really quick. And we don't need that. There we go. And this can go away. And this can go away. There we go. All right. So let's go back to our note sheet here. So our notation-wise, our very first one we had for reflections, we had a capital R, and then in subscript we had whatever our line of reflection was, whether it was the x-axis or the y-axis, or if it was a vertical line or like y equals x or some line of that sort. And then we had our object in parentheses afterwards. That was our notation for reflections. For translations, we have the little arrow brackets, and then we have whatever our change in x is and whatever our change in y is, and that's what we add to our specific coordinates x and y for every single point in our object for our translation. For a rotation, we're going to use a lowercase r, and we're going to have a subscript. The first number that will be given to you will be whatever your angle of rotation is. Remember that angle of rotation, let me get this over here, that the angle of rotation is always counterclockwise. Alright, that is important. Remember that. So we have an angle of rotation, and then we have a point that we're going to be rotating around. Okay. There's two types of rotations that we're going to be working with in our class. So those two cases can boil down to basically working in the coordinate plane, which is what this video is going to concentrate on. I'm going to give you guys some basic rules for doing some really straightforward rotations. Rotations are actually really hard to do, except for a few kind of special cases. For some of the more general cases, we're actually going to do those rotations with a protractor and a ruler. And I'll make another video and we'll spend some more time doing that one in class. That'll be our second case. So our first case is the coordinate plane. Our second case is going to be more of a protractor kind of open space orientation. It's a little bit more drawing oriented as opposed to algebra oriented like we're going to do in today's video. Alright, so the rules that you guys will need in order for us to put together our first rotation. The only rotations we're going to be able to look at are going to be the ones that relate to the 90-degree angles. So we have 90 degrees, 180 degrees, and then 270 degrees. You add another 90 degrees to 270, you get 360, which is going all the way back to the beginning. Okay, so we have 90 degrees, 180, and 270 degrees. These are the rules that you guys will need to write down in order to do these. The rotation for a 90 degree rotation around the origin, that's what this O means that you guys will see in this, see here in the notation here. The O is for the origin. So the rotation of 90 degrees of a given point xy will be of xy will become negative y to x. Okay, so negative y to x. A rotation of x to y of 180 degrees around the origin will just be negative x and negative y. And a rotation of 270 degrees will be y and negative x. Now we could do an exploration. If we had more time and stuff, I'd have you guys do an exploration where we would actually sit down with protractors and objects, and I would have you guys do these rotations on graph paper, and you guys can actually look at these, and you guys could derive all of these rules through your rotations. It actually works really well. It actually comes out very well. Most of these rules, you guys don't need to understand where they come from, but for those of you that are curious, these come from the parallel perpendicular line rules that we did with y equals mx plus b. I'm not going to tie those two concepts together for you, but when you rotate stuff and we have that negative reciprocal relationship of rise over run with our parallel and perpendicular lines, you have some similar results that occur with the coordinates of y and x here. That's where all this comes from. We're not going to worry about really where all that comes from for our purposes today. You need to write down these rules, though. You will need them here in a minute. Let's go back to our triangle now. So the very first point I'm going to have you guys put down, we're going to draw ourselves a basic triangle. Your first point is A, which will be at the coordinates 1, 1. We'll have another triangle at the point, or another point at 3, 1, and a third point at 3, 4. Connect the dots, and we get ourselves a triangle. Okay, the first thing that we're going to do is we're going to do a rotation. We're going to do a rotation of 90 degrees about the origin of the triangle ABC. So where we have the points XY here, we're actually going to have the triangle ABC, which means we're just going to do this rule to the points ABC. So remember, negative Y, negative X for the 90-degree rotation. So on your guys' paper, on your guys' note sheet that you guys received in class, you guys should have some workspace here for doing the 90-degree rotation. I would like you guys to go ahead and do this calculation. For the 3 points that make up our triangle, go ahead and do the negative y and x calculation. Figure out what A prime, B prime, and C prime are. Let's go and stop the video, do that calculation real quick, and then come back to the video. The points that you guys should have gotten when you did your rotation around the origin of this triangle. A prime should work out to negative 1, 1. B prime should be negative 1, 3. And C prime should be negative 4, 3. Connect the dots, we end up with a triangle rotated like that. So once again, if you guys were to draw lines through these 2 points here, you would see that it creates a 90-degree angle. Draw another line. Here, I can actually connect the dots here for you so you guys can see them. If I draw a ray from the origin through B and then another ray through the origin B prime, notice that we have another 90-degree angle. If I do the same thing from the origin through C prime, and then the origin through C, again I have a 90-degree angle. Okay, so we've done a rotation of 90 degrees. Great. All right, now what I would like you guys to do, I would like you guys to do the same thing again. You're going to take the original object that we had here, and you're going to rotate it 180 degrees. Okay, so negative x, negative y for that one. I'll get rid of these really quick. Alright, so we're going to do that rotation now. So 180-degree rotation. That's going to give us negative 1 for our... Here they use A prime again. It's just naming your points. So A prime, B prime, C prime, giving us points down here in the third quadrant. We'll connect the dots, and we get that for our rotation. We get something that's what we call symmetric about the origin. Good. And then you guys can go ahead and do the last rotation. The last rotation is 270 degrees about the origin. Our rule is y and negative x, so go ahead and do your calculations there. So here's A prime, B prime, C prime. Your points are 1 and negative 1, 1 and negative 3, 4 and negative 3. Connect the dots, and there's our last rotation. So the green triangle is a rotation of 90 degrees. The blue triangle is a rotation of 180 degrees, and the black triangle is a rotation of 270 degrees. So that's rotations in the coordinate plane. Those are really the only rotations you guys are going to be able to do. Are those special ones? They have to be about the origin, and they have to be either 90, 180, or 270 degrees. Those are really the only measurements you guys are going to be able to work with in the coordinate plane. Anything beyond that requires more math tricks and a lot more arithmetic and a degree of complexity that's kind of outside the realm of what this class is about. Great, cool. Let me see what else we've got here. Those are your 4 triangles. There is a homework assignment at the top of your sheet you guys can get started on. If you guys have any questions, bring them to class tomorrow, and we will. I'll try to fill in all the blanks there, and we'll have another video, and we'll go through how to do rotations using a protractor and a straight edge.